I am going to start the review of volume and surface area of 3D shapes. I know it's a little earlier than I normally do it. There's not a lot of people here yet. That's okay. You can trickle in, and this video will be up permanently. So, before we jump in, I'm going to review what volume is. So, we work in three different dimensions. So, if we're in one dimension, 1D, we have a line, we get length. Two dimensions, what that means is we have a line going left to right, and we also have the line going up and down. That creates a square or a rectangle, whatever you want to call it. That is a 2D representation of a single line segment. So why that's important? When you find the length, that's the only thing we can really find with this. When it comes to a 2D shape, the space inside the shape is called the area. All that means is you find how much this shape can actually fit in it. So whatever unit we're in, if this is inches, how many square inches are in this? It's just like in a house, when you're looking up houses on like Zillow or something, you'll see the square inches of a house or square feet of a house. That means how many feet in both directions, forward and back. In 3D, we get that same idea for a shape that has three dimensions. So that means left, right, up, down, forward, back. Anything I draw in dotted lines is kind of like the see-through part. So this is what we're going to focus on today. The space inside of a 3D shape is called volume. The next thing we're going to talk about, surface area, essentially is if I got the area of each little panel on this 3D shape. But we're going to focus on volume first. And I'll go ahead and give like a quick definition right down here. So, volume. Volume. The amount of I don't know, the amount of whatever, how much this thing can hold. So let me reword this. Actually, amount is fine. The amount of space that a 3D object can hold. So for back up here, for area, it's how much can fit into this 2D shape. If you're looking at like a plot of land, how much grass can you fill in the plot of land? Volume is how much can be filled into this container. If you have an empty box that you're filling stuff for when you're moving out or something, how much can fit inside the box? How much can it hold? So that's what we're going to focus on. We're going to focus on specifically only a few different shapes because the tests that I'm teaching my students to that they're going to have are only going to go over a few shapes, and this is review, so we don't really need to delve into everything. So we're going to go over cylinders, rectangular pyramids, spheres, cones, and triangular prisms. We will do that here in a second. I also want to give the definition for surface area. So surface area, the definition is kind of in the name, but I'll explain it. I always put equals. So surface area. If I had a 3D shape here, so I'll go back up to my little box. This panel, the one that this square that is facing us, has its own area. This square that's facing to the right has its own area. This square on the top has its own area. So does the square in the back over here, and the square on the bottom. All of those areas added together would be the surface area, i.e. the surface of the figure, the outside of the figure, and how much space the surface actually makes up. So, I'm going to go ahead and write that definition here. Surface area is all of the, I guess, panels? No. Sides. I don't want to make you confused. All of the sides of a 3D figure I'm wording this weird. Surface area, it's all of the sides of a 3D figure. Area added up. Angel, the idea behind this is that I am essentially going off of Khan Academy and just doing kind of their lessons, but in my own way. So I'm glad it feels like Khan Academy. Anyway, we are going to try to do volume and surface area at the same time for each figure. We're going to go one figure at a time. I'll go ahead and start with, I don't know, triangular prisms. So, first of all, identifying your shape is the first step you're going to have to do when you are running into a problem. You're going to get a 3D shape on the screen, on your paper or whatever, and you're going to have to identify what it is. So, let me do prisms first. Prism. Could I possibly apply this to golf? Why are you here? You are graduating tomorrow, and you don't have my... Why are you here? Anyway, a prism is a 3D shape that's made of two parts. The two parts are the faces and what I like to call this, what I like to call the faces and what I like to call the sides. So I know that can be confusing what I mean by sides. There's a bunch of sides. Well, when you have a prism, there's usually two specific sides that are the shape you are working with. I'm going to say that a lot. The shape you're working with. For example, here is what's called a rectangular prism. My face is a square or a rectangle, and the back face is a rectangle. Oh my god, that's terrible. Connecting them gives me this long rectangular box, right? It's like a long box. The sides that are the unique shape. In this case, it's the more square looking sides. That's your face. So you have your faces, and then the other sides, the ones that are connecting them, are your sides. So in this case, it would be this right side, this top side, the left side, and the bottom. Those are your sides and your faces. The faces are also known as, and this is the word I'm going to be using, the base of the figure. So when I say the base of your 3D shape, it is not just the bottom. It means the face, the shape that you're working with. Shape you are working with. So what do I mean by that? Well, a prism doesn't have to just be a square. I'll draw what we're going to go over, a triangular prism. It's two triangles connected by the sides. The triangles being the faces / the base. And these rectangles on the top, on the right, on the left, and on the bottom are these sides. So when solving for prisms, they all follow the same general rule for volume. Let me go ahead and open my notes to make sure I'm not leading you astray. Okay. The basic rule for prisms when it comes to volume. So volume for prisms, they all follow the same rule. V for volume equals capital B times lowercase h. I'll explain what those mean right here. Capital B is the area of the base. Lowercase h is the height of... Actually, Actually, sorry. I'm going to use capital H. I'm going to use capital H because we're going to use lowercase h for something else, and I don't want to confuse you. So capital B times capital H. Capital H means the height of the 3D figure. So this is where the wording can get confusing. We also use lowercase b and lowercase h for base and height for other things. We're going to use it for a triangular prism, but I want to be sure you understand the difference between the capital and the lowercase version. Capital B means the entire area of the base. So like we established already, the base of our triangular prism, where are we at? The base of our triangular prisms are the triangle. The base of this prism is the rectangle. So let's go ahead and do an example so we can understand what I'm identifying. So let's go ahead and draw one. Here's another triangular prism. We have, I'm going to give random lengths. So I'm going to say the side lengths are 10. I'm going to say, well, I'll put it in a different color so you can see it. This height here, I'm going to say is 4. And then I'm going to say the side lengths, all sides of my triangle are the same. Little dashes just mean they're equal. And I will say that those side lengths are, I don't know, 6. I'm making up numbers. So, when I say capital H is the height of the 3D figure, what I mean by height is not actually from the bottom of the figure to the top. It is not from how it's drawn. The height is the distance between the two faces. So I'll put that right here. It also equals distance between the bases. So, what is my height here? What is the height of my 3D figure? I'm going to try to find the volume of this shape. I need the area of the base, and I need the height of the 3D figure. Well, what's the height of the 3D figure? It is not 4. 4 is the height of my base, but it's not the height of the whole figure. The height of the whole figure is the distance between the two bases. My two bases are these triangles. There's one triangle, and there's the other. The distance between them is 10. So I'm going to go ahead and write here 10. Now, capital B is the area of the base. Back up here, area is how much a 2D figure can fill in. What fits in here? So let's go ahead and see how we do that for a triangle. Triangle, all shapes have their own, all shapes have their own area formula. So I'm going to write this. Area, I'm so bad at that. Why isn't it drawing now? Hello? Oh. Area of a triangle. Whenever I put a subscript, I will say it out loud. Area of a triangle is equal to 1/2 base times height. Here is where the confusion happens. Capital B is the area of the base of the 3D figure. Lowercase b is the base of the triangle. Capital H is the height of the 3D figure, the distance between the two bases. Lowercase h is the height of the triangle. When you're finding area, you have to shift away from the 3D shape and look at the 2D figure you're looking at. So now I'm basically gonna grab that triangle, and I'm going to just redraw it here. Here's that triangle. I know the height of the triangle is 4, and I know the base of the triangle is 6. That looks like a B. 6. So now I can plug that into my area. So in this case, area of the base is going to be area of the triangle which is 1/2 base of the triangle times the height of the triangle. So my capital B is the area of a triangle, and the area of a triangle is 1/2 times the base of the triangle, the bottom, times 6, times the height of the triangle, times 4. 6 times 4 is 24. 24 over 2 is 12. So my area of the base, my capital B, is 12. Now I can do the actual calculation to find the volume. Volume is the area of the base times the height of the 3D figure. The area of my base I just figured out is 12, and the height is given to me as 10. 12 times 10 is 120. The other thing you need to know about volume, here, I'll actually put it up here. Length in one dimension is in units. So inches, feet, miles, whatever. 2D is in units squared. So square footage, square yards, square miles. And volume is in units cubed. Hey, the two people watching, you are not even my audience for this lesson. Can you stop spamming my chat with garbage? That would be really nice. Anyway, I'm going to continue. We're going to do another problem with volume, or I guess surface area. So surface area, how am I going to do this? Let's do all the volumes first. Let's do volume for each thing, and then we'll do surface area for each thing. So I'm going to move down. What's my next shape that I'm going to do? Let's see, I did triangular prism. We'll continue the prism and do cylinders. So we have two types of prisms that we went over or looked at. Rectangle and triangle. Well, a prism that has a circular base is its own type of shape that has its own little properties. So we'll do that, and that is called a cylinder. Volume of a cylinder. Volume of a cylinder. So first of all, what is a cylinder? It is essentially a, oh no, like a can. It is a prism that is, where its bases are a circle. It has the same general rule where the volume is equal to the area of the base times the height of the figure. But since it's a cylinder, there's a little bit more that goes into it. Circles they don't have defined sides. There's no length, there's no width, nothing like that. There's only one idea we look with, and that is the radius. So what is the area of a circle? Because that's what we need here. The area of our base is the area of a circle. Our circle is the base. The height is the distance between those. So here's my capital H. And down here, whatever that area is my base. Area of a circle, or how I'll write it normally, a lowercase c, area of a circle, is pi times the radius squared. Radius, we went over that before, but the radius being the distance from the center of the circle to the edge. So all we need to do is plug the radius into this function here to find our area. Once we have the area, we multiply it by the height. And we get our answer. So let's go ahead and do an example. Let's say in this case, our radius is 3. And the height of our entire 3D shape is 12. The volume formula requires us to find the area of the base, so the area of the circle, and then multiply it by the height. So we plug what we know into our area function. In this case, the area of the base, our capital B, is now changed. The capital B will always change depending on the shape of your base. Capital B is the area of the base. This time my base is a circle, so I must use the area of a circle formula, which is pi r squared. So B is equal to pi times, what's my r? Oh, it's 3. 3 squared. 3 squared is just 3 times 3. 3 times 3 is 9, and pi stays put. A lot of, when you get further in math, this is a valid answer. We work with pi very often, but I want to make sure we are going to just... Actually, we're going to stick with that. We're going to leave pi as is. When you get to this point, when you're finding the area of a base the base of a cylinder, and you get like 9 pi or a number times pi, leave it. It'll be more accurate when you plug it back into here. So let's go ahead and do that. Going back to our original function, volume equals capital B, area of the base, times the height. Area of the base, we now know, is 9 pi, and the height was given to us as 12. 9 times 12 is, what is that? Why can't I do that in my head? 108. 108 times pi. So I'm going to open up my calculator, wherever that went. There it is. And I have 108 times pi. Enter. So I get that the volume of this cylinder, whatever units we're in, let's say cubic centimeters. So I'll do that. I'll say cm for centimeters. The volume is 339.29 centimeters squared. 339.29 centimeters, not squared, sorry, cubed. Volume of a cylinder and the volume of prisms follow the same rule. It's the area of the base times the height of the 3D figure. You don't want to get tripped up on what is considered the height. The way you want to think about it is the distance between the bases. In this case, it's the distance between our two triangles. In this case, it's the distance between our two circles. No matter what orientation your figure is in, so this is standing up, this is laying down, this one's laying down, this one's standing up. How you want to think of the capital H height is the distance between the bases. That'll make it so you never mess up what is considered the height. The capital B is the area of the base. So each time you have a base, you have to figure out what that area formula is and solve for that. When you are doing the area, make sure you remember, if you have base and height in your area formula, it's not talking about the base and height of the 3D shape. It's talking about the base and the height of the 2D figure at the bottom. It's talking about the shape of the base. You're looking at that only. You're pretending you don't have a 3D figure. You just have this. 1/2 base times height gets us our area of the base. We plug that back in. Here, even though we're working with pi and a square, I think cylinders are easier. There's only one thing you plug in. One thing you have to solve for. You're always going to know what your height is. You're never going to confuse the diameter. If you confuse the diameter of a circle with the height, I need you to reevaluate things. If the height here is like, you're looking at a soda can. It's the height of the soda can from top to bottom. The distance between the circular base of the can to the top of the can. Let me see what the other shapes we need to do. So we got cylinder. We did triangular prisms. Let's do a sphere. Let's do a sphere. So volume of a sphere is next. Volume of a sphere. A sphere is a ball. That was the best circle I've done on this. Be happy for me. Okay. A volume of a sphere is just this is a ball. A sphere is a ball. That's how you want to think of it. The line around it is just to show you that that's the center of the circle. And just like a circle, a sphere also has a radius from the center of the sphere, so the very, like the core of the Earth, to any point to the crust of the Earth is a radius. So I'll just draw it this way. Radius. The volume of a sphere is very, very easy. Volume equals, and it's going to look not easy, but it's easy. 4 over 3 times pi times r cubed, where r is your radius. The only piece of information that you need for the volume of a sphere is the radius. If you don't like having the fraction here, it might be easier to read it like this. 4 pi r3 over 3. Either one of these is valid. Whatever one you like to type in the calculator, whatever one looks easier for your brain to function with, that works. I guess I'll use the bottom one for now, but I can use the top one. I normally use the top one. I'll use the top one. So let's do an example. Again, the volume of a sphere is the easiest one. You only need the radius. So if I said my radius here was 7, what do I have to do? Well, I just replace the radius with 7. So volume equals 4 over 3 times pi times 7 cubed. I can do 7 squared in my head, but not 7 cubed. 7 to the power of 3. Enter. 343. So volume equals 4 over 3 times pi times 343. I'm going to multiply 343 and the numerator here 4 together. I want to combine everything into one fraction. So 343 times 4 is equal to 1372. Can that be divided by 3? It cannot. Okay. 1372. Volume equals 1372 pi over 3. So now that I'm here, this is what I'll type into a calculator. I'll go ahead and scroll up so we have a little more room. And again, whenever I'm reducing things, I'm showing you a practice that is handy. You can technically plug it in here, but you're not doing much other than replacing your numbers. You're replacing the radius with your number. There's not a lot of math that goes on in there. So I like to reduce it to make sure everything is good and to practice that mentality of reducing and making sure you understand how numbers interact with one another. So 1372 pi. I'm going to do something I should have done at the beginning, is put in parentheses. 1372 pi divided by 3. Enter. My answer for the volume of this sphere is 1436.755 V. I think there's dogs fighting each other outside. Can you guys hear that? Hang on. I gotta see this. There's one owner with 2 dogs, and his dogs were fighting each other. Why? Anyway, 1436.7 0.75. 1436.75 units cubed. Volume of a sphere is the easiest one. You just need to plug in the radius. Usually the radius is given to you. If it's not, it's they give you the diameter and you cut the diameter in half. There's not much else to it. What was next on our list? So we've done prisms, we've done cylinders, and we've done spheres. So we got, I think, rectangular pyramids and cones. Okay, we'll do cones and then pyramids last, and then we will restart this process, but with surface area. And again, there are plenty of other, there are tons of other 3D shapes, but we're only covering the ones that will be on my students' final to make sure they are not confusing themselves with what they don't need. So, volume of a cone is next. Volume of a cone. So a cone, I know you guys have seen like traffic cones or those stupid little paper water cones that they give you at like dumb events where they're like, here's your soda, and it's like lukewarm soda in a little plastic cup. Anyway, here's a cone. The volume of the cone is also relatively straightforward. Let me go ahead and make sure I'm not leading you astray. Great. So, I'm going to draw a little radius line just like before, and I will describe what we need here. The volume of a cone. So how much liquid can this cone fill? How much can fit inside the cone is 1/3 times pi r squared times capital H. I will also rewrite it in a different way that might be easier for some people. Pi r squared H over 3. So, capital H, it's the same kind of capital H as we did before with the prisms. Back up here with the prisms and with the cylinders, capital H is the height of the 3D shape, or the distance between the bases. This time we don't have more than one base. We only have the bottom part. So this time the idea of the distance between the two bases won't work. What will work is understanding that this time there is no other height to be confused with. There is no height that goes into this area formula. It is just the radius. The only height that we work with is the height of the figure. I'm still keeping it capital H because the capital H signifies that we're working with 3D shapes. Let me scroll down real quick. Sorry. All right. So let's go ahead and do another example. Let's say our radius is 2. And we'll say the height of our cone is 12. And let's say it's inches. So 2 inches and 12 inches. Volume of a cone is pi times the radius of the base squared times the height, which is 12 over 3. I'm going to go ahead and do my order of operations. Parentheses first. Pi times what's 2 squared is 4 times 12 over 3. 4 times 12 is 48. I'm moving the pi over just because I like having a number and then pi over 3. I don't believe 48 can divide into 3 easily. I could be wrong. But I think this is a good enough stopping point for me to plug into a calculator, making sure those are in parentheses. So I'll open that up. Parentheses, 48 pi divided by 3. And I get that the volume of this cone is 50.27 inches cubed. A lot of people aren't big fans of working with circles because of pi and because of the squares or the cubes. It's not supposed to be difficult. Pi is there to make it easier for you. Pi is a very useful number, and that's why it's embedded into these calculators. It's in part of the function. So I want you to be less scared of pi and less scared of circles because they're not that challenging. They are literally plugging in one value into an equation that is pretty straightforward. I'm going to do one more volume, and then we're going to move to surface area and be done for the day. So let's scroll down. We're going to do volume of a rectangular pyramid, the easiest pyramid. So volume of a rectangular pyramid. Sorry for my handwriting. Okay, Rectangular pyramid is the kind of pyramid you're all used to seeing. When I say the word pyramid, and for those of you that can picture it in your mind, you probably think of the Pyramid of Giza or Bass Pro Shop. So I'm going to go ahead and draw a pyramid to the best of my ability, which isn't great on this tablet. For those of you that have me in class, you know my drawing on the board is much better, even though it's not that good. Okay, so we got ourselves a rectangular pyramid. What makes it rectangular is the base. The base is the shape of a rectangle or a square. There can be pyramids that are, I'm going to draw it and then erase it to not confuse you guys. There can be triangular pyramids where the base is a triangle. Those are more annoying. And luckily, the final for my students does not have that on it. It has a rectangular pyramid. So I'm going to write the volume equation for a rectangular pyramid. It is 1/3 times the area of the base times the height. If you notice, this is shockingly similar to two things we've already done. 1/3 times the base times the height. Well, where have we seen the 1/3 already? Well, we just did it with cones. And if you look at this equation, 1/3 times pi r squared times the height, well, pi r squared is the area of a circle. So this is still technically area of the base times the height. Area of the base is the circle times the height. The other thing that this looks like is right here. B times H. Capital B times capital H. That is the same formula. I'm going to scroll and scroll and scroll as the cylinder and as prisms. The only difference is that we're dividing our result by 3 or multiplying by 1/3. Another way you can write it is volume equals area of the base times the height of the 3D shape divided by 3. So let's go ahead and do an example of that. Please. Okay, there you go. Let's say this length here is 6. We'll say the height of our 3D shape. I'm putting it in here. We'll say it is 7. And we'll say this length here is 4. Whatever. So let's go ahead and start plugging in what we know. I don't know the area of the base yet, so I won't write that. But I do know the height of my figure. It's 7. Great. And I know the 3 goes on the bottom. So area of the base is what I need. I need my capital B. Capital B is the area of the base. What shape is my base? Well, this time it's a rectangle. It's in the name, rectangular pyramid. I don't know how many of you remember the area of a rectangle. I will go ahead and write this, A sub R for area of rectangle. And it is equal to the length times the width. I'm putting length in capital L because if I put it in lowercase l, it looks like a 1. And if I do a cursive L, most of you have panic attacks because you're not sure what a cursive letter is. So I will use capital L. So the area of the rectangle, the base here, is the length times the width. So our area of the base, B, is length is 6 and width is 4. It actually doesn't matter what number goes into what. 6 times 4 is the same as 4 times 6, which is 24. Oh, the dogs are fighting again. Hang on. That guy looks like he hates his dogs. Anyway, let's go ahead and plug that in. Our capital B is 24. It goes right there. 24 times 7. I probably could do that in my head. I'm not going to. 24 times 7 is equal to 168. Volume equals 168 over 3. We go ahead and divide our answer 168 by 3, and we get that our total volume of this pyramid is 56 units cubed. Before we move on to surface area, I want to I'm going to pause for a second and look at chat to make sure we don't have any more questions about volume. We've done rectangular pyramids, we've done cones, we've done spheres, we've done cylinders, and we've done prisms, specifically triangular prisms. We're going to do those again, but we're going to do surface area this time. Surface area is a little different, but you got to look out for the same kind of things. Surface area of, let's do prisms and cylinders at the same time. Because cylinders are just fancy prisms, but they follow the same rules, just like the volume does. All right, so once again, surface area is if you got all of the sides of a figure, you took the area of each figure and added them together, and you're basically just seeing how much the outside of the shape can hold. Instead of the inside, we're looking at the outside. Like if you had a box in like an art, let's say you made I don't know, like a 3D cube in your pottery class. And it's just made out of clay. You glaze it, and you got to paint it. The surface area tells you how much paint you need to cover the actual surface of the sphere of the shape. So that's what we're gonna do. Let me go ahead and open my notes to make sure I am not leading you astray. Surface area of a prism. All right, here we go. When I do surface area, I put capital S, capital A for surface area. I know that's an acronym for something else. I apologize. Surface area of a prism and cylinder follow the same, essentially the same rules, but they're written slightly differently. For a prism, so for just like the ones we did over here, for these, it follows this rule. 2 times capital B plus capital P times H. We already know capital B. Capital B is the area of the base. That will be the same thing as this capital B. That's why I'm trying to be consistent here. Capital H we already know. It's the height of the 3D shape, and if it has 2 bases, it's the distance between those bases. The only one I haven't described yet is capital P. Well, what does capital P mean? Capital P is perimeter, which is the distance around a shape. Quick example, let's say I have this perfectly drawn rectangle, and I say this side length is 4 and this side length is 6. To find the area, we would multiply those together and get 24. We did that earlier. To get the perimeter, we need to add up all the sides. So 4 plus 6 plus 4 plus 6. So in this case, the area would be 24, and our perimeter would be 20. 4 plus 6 is 10. 6 plus 4 is 14. Or 10 plus 4 is 14. 14 plus 6 is 20. So the only new thing we're adding into our equation is the perimeter. Everything else kind of holds. I'm going to write, this is for prisms, and I'm going to write for cylinders here. They're going to look different, but they follow the same, essentially the same rule. So surface area for a cylinder is 2 times the area of the base plus, I guess I'll write it, the circumference times the height. I'm hesitant to write it this way, but it might make you remember, because B plus CH looks like a funny word. So C equals circumference. And circumference is just a fancy word for perimeter of a circle. If you have questions as to why it has a different name, I do not have the answer for you. They're mean. Who made it up? So this is what I mean by they are the same. They follow the same rules, just like how the cylinders did for volume, but we just made sure that we used the pi r squared for the base. Instead of using perimeter, we use circumference. So we're going to do a prism. I'm going to erase this little example that I did. We are going to do an example of both. We're going to do an example for a triangular. Why is it doing... Excuse me? Okay. We're going to do an example of a triangular prism and an example of a cylinder, and then we'll move on to the next shapes. So, triangular prism first. Let's go ahead and do that. That was the best one yet. All right. Let's go ahead and find the surface area of this prism. We might as well, to make our lives easier, just use the same dimensions we used before. So let's do that. And by our lives, I mean mine. I don't want to keep making up numbers. So this height, please. Thank you. This height here is 4. The base of the triangle is 6. And this length here is 10. Great. Let's move back over. So let's follow each letter accordingly. A good way of doing this, actually, that's how I'll do it. A good way of doing it is set up your equation. SA, surface area, equals 2B plus PH. You have 3 letters to solve for. So a good practice would be over here on the side or underneath your shape, wherever you're going to do it. Let's find B first. Well, I'll do the steps again, but we already found B earlier. We found it over here. Actually, I'm not going to do it again. We found it over here. I'll just talk about it again. I don't have to write it again. How nice is that? So, area of the base. It's the same exact figure. I just drew it with different colors. Area of the base. The base is the shape that I'm working with. It is the face of our prism. So I need to figure out what the area of that base is. The area of that base would be an area of a triangle, which is 1/2 base times height. In this case, lowercase b and lowercase h are the base of the triangle and the height of the triangle. Plugging that in, like we did earlier, we get that the area of our base is 12. Okay, so I'll write that here. Now, really quickly, the reason why it's 2 times the area of the base, because we got 2 bases. We have this area, and we have this one. So we got to take into account both. Because all we're really doing with this equation is saying, if I got 2 of the bases and then added them to the perimeter, the distance around, times the height, I would get the area of all of these sides. So I got my area of the base, B. Let's go ahead and find H. H, capital H, again, is the height of your figure. Not the height of your base, the height of your figure. If you stood this up where the triangle was on the bottom was on the ground and the other triangle was facing the sky, our height, the distance between our 2 bases, would be 10. Last one we need to solve for is the perimeter. So the perimeter is not the perimeter of the whole thing, it's the perimeter of the base. In this case, it's our triangle. Over here, we in our other example, we established that all the sides are equal. So I have 6 plus 6 plus 6. 6 plus 6 plus 6 is 18. I now have all 3 numbers that need to go into this equation. So now I can just plug them in. Surface area is equal to 2 times, what's B? 12. Plus P, what's P? 18. Times H, what's H? 10. And now we just do our order of operations. Multiplication first, making sure we multiply these together and these together separately, and then we add. 2 times 12 is 24, plus 18 times 10 is 180. Now we can add those 2 numbers. 24 plus 180 is 204. And I didn't put units, so units squared. It's area, so it's squared. Volume is cubed, area is squared. We're going to do the same cylinder as before. And this time we're going to find the surface area for it. So let's see what dimensions I gave it. It was 12 and 3. Okay. Can I scroll out? Okay. Let me draw the cylinder as best I can. There we go. I'll do it in a different color. 12 is our height, and our R is 3. I'm going to use this equation. SA, surface area, is equal to 2 times the area of the base plus the circumference times the height of the figure. Circumference of the base, I should say. So once again, I'm going to write my 3 letters that I need to solve for. B, area of the base. Once again, I'll just go over what we did before. We already solved for the area of the base. Area of the base. Our base is a circle, so we must use the circle formula, or the area formula for a circle, which is pi r squared. R is our radius. Our radius is 3, so we plug it in. We get pi times 3 squared. 3 squared is 9. 9 times pi is 9 pi. We're going to use that. We're going to go ahead and say that the area of our base is 9 pi. Let's find the height. It's given to us as 12. Now we find the circumference. So the area, the circumference formula is as follows. 2 pi r. 2 times pi times the radius. So let's plug that in. 2 times pi, and what's my radius? 3. I'm going to combine my 2 whole numbers, so I get 6 pi. So my circumference is 6 pi, my base is 9 pi, and my height is 12. We can go ahead and start plugging our values in. 2 times our base, which is 9 pi, plus the circumference, which is 6 pi, times the height, which is 12. 2 times 9 pi is 18 pi. 6 times 12 pi is 50 pi, right? Yes, right? No. No. I'm bad at math. 6, 12. It's 72. I knew that. 72 pi. 72 pi plus 18 pi is 90 pi. We can go ahead to get our decimal answer, plug that in. 90 times pi. Enter. We get that our surface area is 282.74 units squared, because we are using area. They are very similar. Cylinders and prisms are very similar, both in volume and surface area. It's just the circles are fancy. They have special names for their stuff. Instead of perimeter, they use circumference. Their area formula isn't just multiplying numbers together. It is there's a pi involved and sometimes a square involved. It can be a bit much, but the function that goes into it, the idea behind it, is the same. What is our next shape? Sphere. Okay, cool. The surface area of a sphere is super easy as well. Surface area of a sphere. So, surface area of a sphere. Let me go ahead and draw it again. That's a bad one. I'll get it. Perfect try. We're keeping it. There is a sphere. I will go ahead and draw a radius. And we're going to go ahead and use the same value, 7. So this time our radius is 7. Surface area of a sphere is likely the easiest, not likely, it is the easiest one out of everything we do. Surface area of a sphere is SA for surface area 4 pi r squared. In other words, this right here, pi r squared, is just area of a circle. So it's 4 times the area of a circle. That's it. That's all surface area of a sphere is. So in our case here, surface area is equal to 4 times pi 7 squared. 7 squared is 49. 4 times 49 pi. 4 times 49. So 4 times 50 would be 200. So surface area would be 196 pi. And we can go ahead and plug that in. 196 pi is 615.75. Units squared. So there's not much else to really say about surface area of a sphere. That's it. The most you're going to have to solve for is finding the radius if you're not given it and you're given something like the, I don't know, the diameter. But it doesn't get more complicated than that. That's, you got a sphere. You have one thing you're looking for, the radius. Plug the radius in, and right here you could just punch that into a calculator and be done. I like to reduce it down to here to get the most accurate results. Still going to pause for a second here to make sure I don't have any live questions. And then we got what? Cones and pyramids next. Let me see what those look like. I forget. Oh, nope, don't move. Oh, right. This is that the slant height? Oh, that's right. I'll do that. And then cone. Cone is fun. Okay, cool. Actually, the cone and the pyramid also kind of follow the same rule. So we'll do those at the same time. I don't see any questions, so I'm going to go ahead and move to the last thing we're going to do. Surface, that's a C, area of a cone slash pyramid. So, let me draw a pyramid here, a rectangular pyramid, because that's all that's going to be on the test. That's bad. That's horrible. We're going to do this. There's that, and I'll draw a cone right over here. So for a pyramid, surface area is equal to the area of the base, so capital B, something we've already used, plus 1/2 times the perimeter of the base times a new letter, lowercase s, for slant height. What is slant height? Well, if you were to look at this pyramid here, you have, normally when I say height, you would think from the tip to the base, right? So let me do it in like blue or something. If this dotted line is inside the pyramid and it hits the center of the base and it goes all the way to the top to the point, that would be the height of the figure. That would be the capital H. The slant height is essentially, I'll do a different color, I'll do purple. It is the height of the triangle face. So from the top of the pyramid to the bottom, like you're sliding down. That is your slant height. If you want to think of it as your slide height or something. It's that distance from the top to the edge, sliding. From the center of it to the center of the base, that's the slant height. It's usually given to you. If you can't find it, if it's not given to you, you would use Pythagorean theorem to find it. So that's what S means. We're going to do an example of how to do surface area for the pyramid, and then we'll do the cone right here. So let's give you all the information you need. Area of the base is what we need. So let's go ahead and give this numbers. 5 and, I don't know, 6. And then our slant height. This distance, if we're sliding down and we tracked how far we slid, let's say it is 14. And then we're going to be in feet. Screw it. We're going to be in, that's 5 feet. 6 feet. I'm not going to put feet there, but you know what I mean. So let's go ahead and plug in or write down all of the letters we need. We need capital B, we need perimeter, and we need the slant height. Well, I'm going to get slant height out of the way. It's given to us. It's 14. Great. Perimeter. Perimeter is the distance around the base. So 5 plus 6 plus 5 plus 6. So that's 10 plus 11. That is, no, sorry, 10 plus 12. That is 22. The area of the base, it is a rectangle. So, you know what? I'm going to show the work. So 5 plus 5 plus 6 plus 6 is 22. Area of the base is 5 times 6, length times width, which is 30. I now have all pieces of information to plug in. Surface area is equal to the area of the base, which is 30, plus 1/2 times the perimeter, 22, times the slant height, 14. $30 plus half of 22 is 11 times 14. I can't do 11 times 14 in my head very quickly, so I'm not going to. 11 times 14 is 154. Surface area is equal to 30 plus 154. And the last thing we need to do is add those together. So our surface area of this pyramid is 184 feet squared. Now, the surface area of a pyramid follows the same basic rules, but again, since it has a circular base, it has some fancy things to it. So I'll write it normally, or I'll just do a little arrow over here. So, surface area of a pyramid kind of follows the same rule, but I'm gonna write it out as in the pi form. Area of the base is still first, our capital B. Area of the base is the formula for the area of a circle. Area of a circle is pi r squared. So that's where the B is. Capital B becomes pi r squared. Great. Plus 1/2 the perimeter. Well, we don't use perimeter when it comes to circles. We use circumference, capital C, times the slant height. Well, hang on. If I use, you know what I want to do? You know what I want to do? I'm going to do this. I'm going to do this. Shut up. It was a misinput. Okay. This is the difference. Perimeter has changed to circumference. To make it even more explicit how simple these are, surface area, I'm going to replace the area of the base with the area of the circle, pi r squared, plus 1/2. I'm going to replace C with the circumference formula, 2 pi r times s. Well, 2 divided by 2 is 1, so these canceled each other out. Here is the, I'll put it in a different color so you know this is what I'm talking about. I'll do green. This is the formula now. Surface area for a cone is pi r squared plus pi r s. we only have 2 letters to work with. Up here, it looked like we had 3. Now we only need to plug in 2. The radius and the slant height. Usually given to you. One of each. So you'll have your radius, and then this distance here is the slant height. In this case, let's say our radius is 4, and our slant height is 15. I'm making these numbers off the top of my head. This might not look good. I'm going to write down the numbers, the letters down here to solve for, but we don't even really need to solve for them. The radius is 4, and the slant height is 15. We plug them in. Pi times the radius squared plus pi times the radius times the slant height. Surface area equals, well, 4 times 4, 4 squared, is 16. So I get 16 pi here. 15 times 4 is 60. So I get 60 pi. 60 pi plus 16 pi is 76 pi. So my surface area of this cone, 76 times pi, is 238.76. 238.76. I used feet over here, so I'll just say feet squared. And that, I believe, is the last piece of surface area we need to cover. Let's see, we got pyramid was last. We did pyramid. We did cone. We did sphere. And we did prisms and cylinders. Yeah, that is it. We got prisms and cylinders who are very similar. Cylinders just have some special things that go into it. Spheres are the easiest ones. There's only the radius you got to worry about. Surface area of a cone and pyramid are also pretty simple. You only need a couple things. Usually the slant height is given. And earlier I said, I guess I'll do a quick showcase of that. Earlier I said if you're not given the slant height, you would have to solve it using Pythagorean theorem. So let me kind of do a little example of what I mean. This is if you don't, oh my God. This pen that I'm using has a little button towards the tip that I guess is useful if you're good with your dexterity, but my thumb just keeps pressing it and it just keeps randomly clicking thing. I don't know what it's doing, but while I'm writing, I'll click it and it screws everything up. So I apologize. If you don't have S, your slant height. So I'll do it with a cone. It's the same as if you didn't have it here. Let's say they give you a radius. So they give you the radius is 3. And they say the height of your cone is 10. And you need to find S. Well, right here, we have ourselves a little right triangle. And we get to use our favorite equation, Pythagorean theorem. A squared, that's not a square. A squared plus B squared equals C squared, where C is your hypotenuse. Hypotenuse being your biggest side. In this case, our slant height. So A squared is 3 squared plus B squared, which is 10 squared. Our hypotenuse, our C, is the slant height. And now we solve. 3 squared is 9. 10 squared is 100. And I'm left with S squared. 9 plus 100 is 109 equals S squared. I have to square root both sides. Square root 109 is equal to the square root of S squared. Square rooting something that's being squared cancels it out. And all I'm left with is the slant height. I'm going to go ahead and find the square root of 109. And it's 10.44. So in this case, my slant height would be 10.44. And then from there, you can do the rest of the problem. So that will happen sometimes. I forget if that's going to be on the test. But if you don't have one piece of your information, you can use Pythagorean theorem to find the other. So if it's asking for the height, if they're like, if the slant height is this and the radius is this, you can use Pythagorean theorem to find the height. That all being said, I believe that'll do it for the night. Thank you for those that watched. If you are not watching live, this will be available forever in my catalog of videos. Hopefully this was helpful. Please ask questions if you have any. I'm a sucker for questions, as most of you who know me in real life know. Put them in the comments or email me them if you're one of my students. And yeah, have a good rest of your night. This will be the last stream of the week. I have graduation to go to tomorrow and then personal engagements on Friday. So this will be the last stream of the week. I might do a stats review on like the weekend, like a really quick one, but we'll see. All right. That should do it.